Hi. So here we have a vector problem. And what this says is using a diagram, a vector diagram, find the resultant of these forces. What does the word resultant mean? Well, it's the addition of these two vectors together. This could be something like 4 newtons in this direction, and this could be something like 7 newtons in that direction. I'm not so interested in the numerical value. I'm interested in actually showing the vector arrow, which represents the summation of these two. In order to add vectors together, we simply draw one of the vectors down in a free section of our diagram. I'm not using a ruler with this system, although frankly, if I was doing this for real, I would be using a ruler. It's good to have a nice straight line for a vector, and the important thing is you have an arrowhead on there. And the process of addition is taking this 7 Newton vector and adding it to the initial 4 Newton vector. And for that, basically what I do, the process of addition is attaching the head, the tail of the second vector on top of the head of the first vector. The pen decided it didn't like what I did there, so we have that. So this is our 4 Newton vector. This is our 7 Newton vector. I've not swiveled them. I've not stretched them. I've just slid them across the page. And the key thing is that the answer, the resultant, starts at the tail of the very first vector and ends at the head of the second vector. So this would be our resultant. It's often shown with a dotted line. It must have a arrowhead on, and it goes from the very beginning of your first vector to the very end of your last vector. And in principle, that's just the process of addition that we do over and over again in vector diagrams. So there we have it.